Hey guys, today I'm going to teach you how to compare and order real numbers. So far we've learned about rational numbers, irrational numbers, and so on. Today we're just going to put those in order from least to greatest on a number line. So we'll be able to compare rational and irrational numbers when we're given a set. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. Let's get started with a review of what these symbols mean. So when we compare numbers, we can compare using these inequality signs. Remember, inequality means not equal to. So these are the signs that would come in place of an equal sign. Let's get a closer look at those. So there's four that we're going to look at. There's the greater than, the less than, the greater than or equal to, and then the less than or equal to. And then sometimes you'll be able to see this not equal to at all sign, but we'll look at that a little more later. So let's start with the greater than sign. So I always like to look at these like an alligator, and it eats the bigger number. So this is the eyeball, and it's got little teeth here. So it's an alligator that eats big numbers. So whichever way it's facing, that's the one that it's eating. It eats bigger numbers because it's an alligator. It's really hungry. It wants to eat the bigger numbers. You can also think about it like it's pointing at the little guy. So if you point at the little one, it's pointing at the smaller number. But I like to think about it like an alligator. So the same thing works here. You can look at the greater than or equal to sign. You can see your alligator, and then it's eating bigger numbers. Or, because it could be equal, it could be that number. So if there's a little line underneath of it, that's like an equal sign. So like an equal sign would be like this. They've just taken out the top part and replaced it with the inequality symbol. So inequality because it's not equal, but sometimes it could be. So for example, when you have like a 4 could be greater than or equal to x, that x could be 4. It could also be all numbers that are less than 4 because it's eating the 4 and it's pointing at the little guy. So all these x's could be numbers that are less than the 4, or it could be a 4 itself. So the same thing is true for this less than symbol and this less than or equal to symbol. It's an alligator and it eats the bigger number. So whichever way it's eating or facing, those are bigger. So on this one, if it was x is less than 5, all numbers below 5, like 4, 3, 2, 1, and so on, could be this x, but it cannot be 5 unless you have a less than or equal to sign. So if you have it written like this, it could be like x is less than or equal to 5, then the x could be 5, but it's also 4, 3, 2, 1, and so on. So just pay attention to which way the alligator is facing. So the only way you would see this not equal to sign is if two numbers are not equal to each other, and there's no variable. So if there's just two numbers, I know that a 4 is not the same as a 5. I would use a not equal to sign, but we're not going to use this today. I just wanted to show you that because we'll get into that later on. So if you haven't already, go ahead and fill in these blanks. This is the greater less than symbol, and this is the greater than symbol. So those symbols are going to be important today because when we order numbers, we compare numbers. We're going to be able to compare these values using inequality signs. So like comparing 2 and the square root of 8, we'll be able to compare those. We'll know which one is bigger, and we'll be able to pull that sign out. So these might be helpful for you to pull out that number line that we looked at with the numbers and the square roots on it. So if you have that number line in your notes, I'll pull that out. This section right here, you're going to want to simplify anything you can simplify first. So if you can simplify the square root of 8 or approximate the square root of 8, you should go ahead and do that. So because I know that the square root means what number times itself gives you the number inside, I know there's not a number that gives you 8 because 2 times 2 is 4 and 3 times 3 is 9. So I know it's between 2 and 3, but I know that it is not a perfect whole number. I can probably approximate this number to be about 2.8. So I'm going to go ahead and write above that just a little 2.8 just because I know that it is close to 3 because 3 times 3 is 9, but not quite. So the square root of 8 is greater than 2. So I want to go ahead and put an inequality symbol like that. It's like an alligator that's eating that 2.8. So it has to be eating that. So it's pointing to the little guy, pointing to 2. So this would be the less than sign. So we'll do the same thing with the next one. We have a fraction. So if we have a fraction, we can always simplify it because that line means divide. So I'm going to simplify that by doing 5 divided by 2. So when I do that, I get 2.5. And this is a negative value. So I have to think, would I rather owe somebody $1.50 or would I rather owe somebody $2.50? I'd rather owe you $1.50. That's closer to 0. So I have to put a greater than symbol in there. And in these examples, I'm comparing two numbers, so I'm not really going to use that or equal to sign because this is not equal to this. It's only greater than. Go ahead and try this next one on your own and then pause the video, try it, and then press play and you're ready to check. Okay, so by now you should have tried this out. So you probably looked at the square root of 145, realized that it was close to 144, which is a perfect square, which is close to 12 and just right above it since it's 12 times 12 is 144. So the square root of 145 would be 12.04, about 12.1, 12.04, somewhere in that ballpark. But either way, you know that 12.5 should be greater. So you're going to make sure that your alligator is eating the bigger number. If it helps you, you can draw your little eyes on it, your little teeth. If that helps, you're more than welcome to do that. But on a test or anything official, you'd want to leave it like we were doing here and here. So let's go ahead and look at some vocabulary for ordering. So lists of values can be ordered from least to greatest or greatest to least. So sometimes something will say order from least to greatest. Sometimes things will say order from greatest to least. So there's different ways that we can write that. There's some clue words. For least to greatest, we might see words like ascending, like you're climbing stairs from the bottom to the top. Another word starting low and getting high could be increasing, or minimum to maximum. So we need to know these key words so we can understand what a question might be asking us. If it says order from least to greatest, we'll know we need to order from smallest to largest. If it says list in ascending order, I know I need to list from least to greatest or smallest to largest. In increasing order or minimum to maximum is the same way. So other times math questions will ask you to order numbers from greatest to least. To me, this feels backwards, but sometimes it can be useful in math or science to list the greatest number first and then get smaller. Even in sports, we might want to list our tallest basketball players and then go from there to get our shortest. We might want to list the highest scores in games and then get to the lowest scores. So sometimes it's better to be for winners or for measurement or comparison in that way to list from greatest to least. So here are some keywords for greatest to least. One of them is descending. So if ascending means you're starting low and getting higher, descending means you're starting up and going down. I always like to think about those two words like you're climbing stairs. Ascending would be you're climbing up the stairs. Descending is you're going down the stairs. You can also think about like a plane. Whenever you get in a plane and you go up, it's ascending. And then when a plane lands, it's descending. The next word could be decreasing, which again is the opposite of increasing. And then the last one, maximum to minimum. So you always want to pay attention to what the question is asking. So let's go ahead and look down at the next section where it says, when comparing or ordering, it is helpful to first represent the values in the same form. So if you're given all of these different values, let's say you're given 1/3, 0.2, 50%, we can't compare those until they're in the same form. We cannot compare these until they are all fractions, all decimals, or all percents. So we know that fractions, decimals, and percents are the same thing, but they're different ways to represent the same thing. So we want to make sure that they're all in the same form. And I will tell you now, I think the most useful way to compare numbers is whenever they're in decimal form. I think that it's easiest to compare numbers when they're in decimal form. So the first thing that we're going to do is going to convert all three forms of the numbers below. We'll start our first example with the fraction. So in our first lesson, fractions to decimals, we learned how to do fractions to decimals without a calculator. If you have a calculator, you know that that line means divide, and you would do 1 divided by 3. If you want to challenge yourself, you can do all of these without a calculator. If you want a shortcut, you can use a calculator. And if you want to be really, really good about this, I would try it without a calculator if you have time, and then I would check it with a calculator. I think that's probably the best method to do this right now. So we'll go ahead and we'll just figure out 1 divided by 3. I got 0.3 repeating, so I don't have to put 0.33 or 0.333. I can just put the first 3 and put a little line over it. That little line on top of it means that that number is repeating. So this is a rational number because 1/3 is a fraction. 0.3 is a repeating decimal. These are rational numbers, and these are both the same thing, just different ways to write it. So the other way to write a rational number like this is as a percent. So percent literally means out of 100. So when you turn a decimal into a percent, you need to move it to the hundreds place. You need to move it 2 times. That's where the hundreds place normally would be. So in this case, we have 0.3. So and it's repeating. So I'm going to have to write 0.3, and I'll go ahead and write another one and another one just to make sure you can visualize this. So again, it means out of 100. So right now it's the decimal point is here behind the tenths place. I want to move it over to the hundredths place because it means out of 100. So whenever I see a percent, and it's a decimal, I'm going to move the decimal 2 times to the right. It'll work every time. So the decimal, again, is here, and I'm going to move it 2 times to the right. That's how you turn a decimal into a percent. So this is now 33.3%. The percent sign is a slash with a dot on either side. So 33.3%. In real life, you could make 1 out of 3 free throws. You would have had a 0.3 as your decimal, and you would have a 33.3% free throw average. So knowing the decimal is really important because now I can compare these two right here and already tell you that 1/3 is greater than whatever these fractions and percents are going to be. But we'll go ahead and practice by converting this decimal to a fraction and then to a percent. So I'm going to start by making this decimal a fraction. I would read this as 0.2 or 2/10, so I can write that as 2/10. You also want to go back to your notes on how to convert decimals to fractions, and you would have the thing about multiply by 10 till you get the decimal out. I know the shortcut is that I can just read this decimal as it's a 2 in the tenths place, so 2/10. And then I always want to simplify if I can. So no 2 goes into 2 and 2 goes into 10 to make 1/5 as the decimal or the fraction equivalent to the decimal 0.2. So 0.2 and 1/5 are the same. If you think about it like this, you could have 20 cents. That's the same thing as having 2 dimes. Now let's convert this decimal to a percent. So I always want to rewrite 0.2, and then I want to add zeros. If there's nothing after it, there are zeros. And percent means out of 100. So I'm going to take the decimal, and I'm going to move it 2 times to the right. So when I turn a decimal into a percent, I move the decimal 2 times to the right. You should write that down. So my new percent is 20% or 20.0%, but since everything has a 0.0 behind it, I can just leave that as 20%. So I've done 2 examples for you. If you get the gist of this by now, you can go ahead and try the rest of these, but I'm going to go ahead and guide you through these next 2. So I'm going to guide you through the next 2, and what I want you to do is to kind of go along with me, pausing so you can practice and then pressing play to check. If you still don't feel like you have it, just stick with me and pay attention to my example. So we have a percent first. So the percent is already given to you out of 100. So to turn a percent back to a decimal, I'm going to have to move that percent back to the left 2 times. So I'm going to undo what I did. So over here, I was moving the decimal 2 times to the right. Since it's already been moved, I'm going to move it 2 times to the left. So to get from a percent to a decimal, I'm going to move that decimal 2 times to the left. So it's automatically at the end. I know that because it's a regular whole 50. So there's an invisible decimal at the end, and it goes 2 times to the left. That makes it 0.5. So 0.5 is the same thing as 50%. Think about it like money. If you have 50% of a dollar, you have half a dollar or 50 cents. So I just gave you the answer here for the fraction part. If you have 0.5 or 50%, you have half. If that was your test score, you got half the questions right. If you're a 50% free throw shooter, you make 1 for every 2 shots. So I'm going to go ahead and go through this a little bit quicker now. I'm just going to go ahead and put the answers up for the next section. So just go ahead and try these next ones by yourself and then press play to check. So here are the answers to this section. If you had any questions about finding any of these, this is the first thing you should bring to me in class. Now that they are all converted into the same forms, it's way easier to compare. So now I want to look at the decimal column, and I can tell you just by looking at the decimals which one's the greatest, which one's the least, and so on. So for example, 1.5 or 1.5 is the greatest because it has something in the ones place. The next greatest would be 0.75 because that 7 is in the tenths place, and it is the greatest number in the tenths place. So we can compare when we're looking at the decimal versions of each number a lot easier. So we always want to convert to a decimal. So let's practice that here in this section by comparing the following values and placing an inequality sign in the box. So we're going to put together everything we've done so far. So we are given a fraction and a decimal. We want to make sure we convert our fraction into a decimal. So go ahead and pause now, convert this fraction, -7/8, into a decimal. And then if you want to go ahead, you can compare by putting the inequality symbol in the box. So by now you should have tried that. What I did is I divided 7 divided by 8, and I got 0.875, it's negative, and this is negative 0.5. So if I looked at this on a number line, I would know that the negative 0.5 is closer to 0. It's closer to the right, whereas this negative 0.875 is closer to the left. It's a bigger negative, so it's less. So when we're looking at negatives, the bigger the negative, the less the number is. You'd rather owe me 50 cents than owe me 87 cents. So that's how I could compare them as decimals. And obviously, like I just said, I know that this is greater. I could also look at these as fractions. So we looked at above how we could make these fractions. If you didn't want to make that a decimal, you could always try a different strategy. So you already have negative 7/8. So we could also convert this to negative 1/2 since we already did that up there. If you want to make this equivalent fractions, they have to be equivalent to be compared. You know that 4/8 is the same thing. So you know that 4/8 is the same thing as 1/2, and it's negative. So then you look at these numbers, you know that a negative 4 is greater than a negative 7. If we were looking at it with underwater, negative 7 is deeper than negative 4. So again, greater than. Let's look at number 2. This one I want to do with you to start out with, just because you have something that you might not have seen before. You see a pi squared here. Pi is approximately 3.14. So we celebrate Pi Day on March 14th because it's the third month and the 14th day. So 3.14 is the approximation for pi. But remember, pi is an irrational number because it never ends and it never repeats. So we can get close to the square to pi squared, but we can't know exactly what pi squared is. So we know that it is about 3 times 3 because it's 3.14 times 3.14. So it's about 9 something. So I might use my little about symbols. It's about 9. And then the square root of 50, we can approximate by looking at our irrational square roots number line. I know that the square root of 49 is 7. So I know that this is about 7 point something. So it's about 7.1 or 7.01 because it is a little bit bigger than the square root of 49, which is 7. So I can look at this at 9 and a 7 now and realize that a 9 is greater. So that's all we're doing, guys, just converting numbers to decimals and then comparing them. You should try the next 3 by yourselves and then press play when you're ready to check. So you should have tried these by yourself now. I'm going to just go ahead and give you the answers pretty quickly. For number 3, I know that these are both the decimal equivalents of negative 0.6 and negative 0.75. So I know that negative 0.6 is greater because it's closer to 0. I know for a quick shortcut on number 4, I know the square root of 60 and the square root of 63 aren't going to be too much different from each other. So when I'm adding 5 to this one and 4 to this one, I know that this one's going to be bigger just because these are about the same square roots and the 5 is bigger than a 4. So this one's going to be bigger. So for this last one, number 5, we have the same time minutes. We have 35 and 35, so I can just ignore those. We're just going to compare the 0.25 and the 1/6. 1/6 is the same thing as about 0.16 with a repeating decimal. But what it's asking you is who finished their chores the fastest, so who has the faster time. So this is Derek, because Derek got his done in 0.16, where she got hers done in 0.25. So faster is a smaller time. So this would be Derek. Because again, faster is the smaller time. So these are the next set of practice problems that you should try by yourself, and then we'll review them first thing in class. I'll have an answer key posted, and you'll be able to check your answers. If you have any questions about those, please let me know. All right, guys, that's it. If you made it to the end of this video, please put your favorite musical artist in the comments. Today we went over comparing and ordering real numbers. So now you should be able to put rational and irrational numbers in order from least to greatest or greatest to least on a number line. Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.